Students, so I'm going to introduce you to the uh, FCAW Flux Core Arc Welding weldment today. And I'm in a little bit different of an angle shot. I'm more of a wide angle instead of the up close one because there was a couple of things I wanted to show you to better prepare you for this weldment as well as the uh, GMAW. So we're doing with dual shield, what is commonly referred to as dual shield. Um, this weldment, when you're dealing with flux core, you can run a gas, but the wire has a flux on it already. It is processed with the wire, so it can be used outside. It's a very nasty weld. A lot of you aren't going to like it because it's just going to spit and sputter, and you're going to have flux on it. You're going to have to chip the flux away. But it's a very easy process, much like GMAW. And so it's just a matter of hitting the trigger on the gun, and the weld, the process begins. But again, it's a very nasty weld. It's a very hot weld. You'll notice that I have my machine, my voltage set at about 22.4, 22.5 amps. That's what you want to run at. And so we're going to start setting everything up. So I've already transferred my wire over. You want to watch the video on how to set up for GMAW. The process is still the same. We're going to switch the wire over and set up for dual shield. And we're going to make sure that our rollers and our contact tip. It is important that you understand, even if you didn't do well on the MIG gun test, it is important that you understand the different components, at least the basic components, the gas nozzle, the contact tip, the diffuser, okay? The contact tip and the diffuser, and the gun body itself, the basic components. Inside here is a liner, that you understand the basic components of your MIG gun, right? So that you make sure that you have the right size contact tip. You should have a 4-5 contact tip. If you've got wire running through it, 3-5 obviously won't fit over a 4-5 wire, right? And then your gas nozzle as well. Okay. We're back to using 1/4-inch plate, or a 1/4-inch flat bar. And so we won't be using just the 1/8 inch. We'll be using that on the GTAW, on the TIG weldment. All right. Here's our gas. And so we're going to open it up all the way. We're going to make sure that we are set at about between 20 and 25 cubic feet per hour. So we're going to check right there, make sure that ball comes right up about between the 20 and 25. And once we have that set, then we're good to go. All right. Again, we're going to make sure that we're set on intershield. If you're running the Lincoln, you want to make sure you're set up on intershield. If you're running the Millers, again, just leave it set up on MIG. All right. Got our bolts set. We've done our pre-check on all of our cables, making sure that our ground is hooked up, making sure that our electrode is hooked up from the wire feed unit itself, making sure that our remote control is hooked up correctly. No need, please do not unhook my gun in any way. Please do not unhook my gun. Okay, we want to leave that secured in there because there's rubber grommets inside there, and that's also what feeds the gas to our gun to give us a good coverage to make sure that we're getting our finish your sentence, Mr. Clark. You start a sentence and you just quit in mid-sentence. Yeah, I know, it's old age. You also that gun also provides the covering for your flux. Provides the gas shield for your flux. Okay, so we're going to set these up just like we've been setting them up before. We're going to take our two pieces and split it. We're going to tack it here, and then we're going to set up our fillet weld on top. All right, just as we've done before. And just a quick tack on the end. And you want to watch that if it starts to burn up inside there like it just did with me. You want to be careful, not let it do that, because that could mean that your wire speed is not running fast enough, or it could mean that your rollers are too tight. You want to be careful because you don't want it to burn up inside and destroy a contact tip, okay? So and then we're going to set our fillet weld right in the center. One of the things that I've noticed with the GMAW process is some of you are running at a true 90. What happens, and let me run my wire out here. What happens when you run at a true 90, and I know it's difficult to see on the screen, is your weld puddle is going to be too far away from where your base metal meets and your weld is. Okay, it's imperative that as you're welding, you're watching that weld puddle. You're not going to be at a true 90 as you were with FCAW, because you've got this gas nozzle in the way. You're going to be between a 90 and a 45. Okay, let me cut this just a little bit so I can get a little closer to my metal. Okay, you're going to be a little bit almost at this angle right here. So you can watch as that weld puddle washes up between the joint here. Not at a true 45, okay, but almost at this angle, about like this, all right? And you're watching that weld puddle as it washes up on the connection, on the joint right here, all right? This is a backhand motion, and so we'll be pulling the puddle. We'll be pulling the puddle this way, okay? And so, again, 2-pass, 3-pass, 2-pass on the bottom, 3-pass on the side, just like we've been doing. All right, and I'm going to kick through a couple of passes for you just so you can see how this welds. All right, here we go. And sometimes it gets stuck up in there. Here we go. It's a very hot weld. It welds very quickly, very hot. Okay, and that's what it looks like. Now, there's slag on here, and so you're going to want to take your chipping hammer and clear that slag off of there. Now, fortunately, you don't have to beat it to death like you did with the FCAW weld. Okay. Yeah, but that's what it should be looking like. All right, and I'm a distance away, so you really can't see it as well. All right, and then just as we did before, we're going to run our top one. Then we're going to run at a 45 right on top of there, right on top of there. Okay, here we go. Didn't mean to run it all the way to the end. I got so excited there. I was like, oh, weld. I don't get to sit in the booth and weld very much without. Okay. And this thing is already smoking hot. It's already smoking hot. Okay. And again, I'll have this sitting out waiting for you to take a look at whenever you get here. All right. But that's what it should look like. All right. And again, you can see down here, and I went too far with it, and I'll redo one on the other side for you. But you see about a third of my first pass on the bottom here. Okay. All right. 3 passes, again, are all pretty easy. 45, 45, 45. Okay. All right. I'm going to set this metal up where I want it. And here we go. Again, a nice 45 here. Nice 45 here. Again, going to chip that slag out of there so it cleans up for us nice and clean. And the trick with this one is to stay moving quick enough so that you stay, okay? And now I'm going to go right at the bottom of this toe, boom, right across here, okay? And I'll run about halfway. Here we go. This is a very easy process. Okay. Of course, this weldment is getting hot, so it's pulling the weld into it, pulling the metal into it. All right. And now I'm going to run one more right across the top, right on top of that toe. And here we go. Bang, boom, pow. What I'm looking for on this one, especially on this 3-pass, ouch, ooh, ooh. What I'm looking for on this 3-pass is that you're not blowing out the top edge here and you're not overrunning it. And I can still see part of this bottom weld here. That tells me that you're running with a good consistency and that you're running at a good speed. Okay. But basically the principles are all the same. You want a good consistent. If your weld bead is the same size, you're running the same speed. All right, that's what I'm looking for. I'm looking for consistency. Consistency is king with every weld we do. SMAW, GMAW, FCAW, GTAW. Consistency is king in everything we do. Ladies and gentlemen, that's it. I'll see you in the booth. I'm out.